Hello everyone, welcome to this exciting video where we will dive into some core concepts how the computers work behind the scenes. So, I'll introduce some concepts in this video with some real life examples so that you will have a super easy understanding capability. So, initially, I have two questions for you. I have wondered how your computer ensures security while running programs, or why some programming languages run faster than others. So, to answer these questions, we need to discuss these endure important topics which are really important to understand the computer and the computer working in the behind scenes. So I'll show you a slideshow so that you would understand each and every topic with some real life examples so that you will be beneficial with this video. And coming to the next slide, I have first user mode and the kernel. So what is the necessity of this mode? So here are the four necessity of this mode. I'll tell you what are these. To prevent accidental or malicious system damage, to ensure stability of the operating system, to have some efficient and memory match, and also to have some security to your system in order to protect from the cyber attack. I mean, to ensure your file safety, to ensure your file security, and to ensure your OS operating system a very in an efficient way. We'll use this two modes, which in our computer will have these two modes. I'll also explain what are these modes. Coming to the next slide, we have user mode and the kernel. A computer operates in two modes generally, user mode and the kernel. So, user mode is where applications like browsers and games run with some restricted access to system resources. And kernel mode is where the OS core operates with full control over hardware and the memory. I mean, I hope you're getting the difference between this user mode and the kernel. Let me tell you. User mode is where apps run with some restricted access, and the kernel mode is where the OS code runs with full control. I hope you're getting my point, and so I think you're getting some differentiation points for this user mode and kernel. Let me explain it deeply. So, what is the big difference between these two modes is that if something crashes in the user mode, only the program stops, but in the kernel mode, the crash can take down the whole system file. I mean, why this happens because user mode has some restricted access. I mean, it has some passcodes or security to save your files, but in the kernel it is full control under your arms. I mean, you can change your own things as per as your requirements. You have your own security for this country. And see this diagram where the user mode and the kernel mode are connected. I mean, they both are differentiated in the system with the line where some other protocols are present in this between two modes. And for example, I'll give an example how this user mode and the kernel mode are present in your system. To open a browser, to browse the internet, user mode cannot directly access the hardware. You cannot access the direct hardware from this browser, right? You cannot access the entire hardware from this browser, right? So you know it. So this is where the user mode is working. And comes to kernel here, when you install a new driver for a printer or a keyboard, the OS runs it in the kernel mode for full access to the hardware. I mean, when you're installing a new driver, you will have access to that hardware, right? So here, the difference between the user mode and the kernel mode are coming to noting. I mean, to know your hardware, to interact with your hardware, kernel mode is used, but you cannot interact with hardware in the user. You remember this point, my dear friends. And coming to a small analogy, which is a real life example about the hotel management. So, uh, you all know that we'll go to hotels. I mean, guests visit some hotels, right? So, imagine user mode as a guest in a hotel, and you can use the facilities, but you cannot control the hotel's operations. I mean, guest cannot control the hotel operations, right? Like as user mode cannot control the hardware. In the same way, kernel mode is like Hotel management, having full control. I mean, you have the access to the hardware. I hope this example is bringing a correct connection to this modes to your computer, right? I mean, user mode works as a guest, whereas the kernel mode acts as a hotel management, which has a full control like kernel mode has. Coming to the next slide, we have system calls. What are the system calls? So I have a question for you. How do user mode programs access kernel mode services? I mean, there is a connection between this user mode and the kernel mode in our computers. So, user mode programs have some services from the kernel. In order to get those services from the kernel, system calls are used. Here, system calls acts as bridge between user mode and the kernel. So there are predefined functions that allow programs to interact with operating systems, whereas opening file, reading file, writing file, sending data, etc. These all acts as some functions. So these functions are acting between the user mode and the kernel. So how this user mode uses the facilities of the kernel mode? How can we make the balance of these two modes? So here the bridge is as system calls. So see this diagram. In the user mode, your code is executing, and you open a file from the scope, and also your now system call enters. Why system call enters? To execute as code in this kernel, the system call helps to access the service from the kernel to the user, right? From the kernel mode, the service is coming to this user mode. How does it coming by system call? So it again returns your code and the work of the user mode complete by the service of the kernel by the help of system call as a bridge. I hope you're getting my point. And next, for a real life example, I'll show how this analogy. I hope you all have idea of restaurant, right? When you visit restaurants, you will order something, right? You don't order directly from the kitchen, right? You just interact with the waiter, so that waiter interacts with the kitchen, right? So there is a bridge. Who is the bridge? Waiter acts as bridge between the customer and the kitchen. So here is what the system call is. Waiter, that means system call. Here the system call is the waiter. User mode is the customer. Kernel mode is the kitchen. So the when a customer needs to get food from the kitchen, waiter acts as a bridge. So waiter acts as the system call. I hope you got my point, right? You will easily understand this analysis. So, like a live example, when you copy a file from the USB to your system, the system call is used to read and write it. So, here the system call is used. Mm, so next topic is compiler and the interpreter. So programming languages use either a compiler or an interpreter to convert your source code into the machine code. In order to make your code understand to this machine code, we use here compilers and the interpreters. So what is the difference between compiler and interpreter? Are they same? No, they are not at all same. A compiler translates the entire code before execution, making it faster. An interpreter translates and runs the code line by line, making debugging easier but execution slow. There are some advantages and disadvantages in both of them. So, in short, we'll say that compiler is which converts whole code before the execution, right? And the interpreter executes code line by line. So, it's a little slower than the compiler, as you know. So here are the difference between the compiler and the interpreter. Uh, how speed, example, right? C program codes works with the compiler and the Python and the JavaScript codes work with the interpreter. This is a very most important point in which some interviews ask this question like C is worked on compiler and the Python is worked on the interpreter, which executes line by line, right? I hope these differences make you out clarity between the compiler and the next. Uh, as I said, I'll give you a real life example for the compiler. For the book, full book translation before reading. compiler works, like live translation scheme, sentence by sentence. When you want to interpret it, then definitely interpret counts. So I hope you're getting my point. Compiler is when to execute the entire code after the code written, whereas the interpreter works as line by line, so sentence by sentence. So I hope you're getting my point. Then next topic is Java virtual machine. So here comes the Java virtual machine is an interpreter that allows Java programs to run on any operating systems. I mean, when you want to use Java programs to run onto your system, you need to have JVM, Java Virtual Machines. To work with many systems, like if you want to install any new applications, Java applications, where you use Java programs. We install generally Java virtual machine, which also have a little process. This Java virtual machine helps to work with this Java program in your operating system. I mean, JVM makes your system to interact with Java programs so that everyone will be beneficial with this JVM. So instead of compiling directly into the machine code, Java is converted into byte, which the JVM translates based on the OS, right? JVM allows Java to run on any OS, converts Java bytecode to machine code. So here the JVM acts as bridge between the bytecode and the machine code. It converts bytecode to the machine code. JVM allows Java to run on any. So what here JVM is doing is that it's compiling your code into the machine code. How? So it converting the bytecode into the machine code. So the JVM translates based on the OS. I mean, to interact with the Java programs in your OS system, you need to develop a JVM called Java Virtual Machine so that you can interact with the Java programs according to your OS. And here is the diagram for it. See, you can see that Java program, from the Java program, Java compiler, and to the Java compiler to the JVM. And according to your own operating system, your own hardware platform, and the output and this. I hope you're getting to know this slide and comes to the next slide. If you want to check it, you can pause your video and you can check on this diagram. And the next is, so there is a real life example. So JVM is like a charger that works on different sockets on any socket. I mean, you can charge your system or charge your mobile according to any different socket using this JVM. So this JVM is acting like a bridge, right? So here JVM is like a charger that works on different sockets. And when you run a Java program, the JVM converts it into bytecode and allows it to run on Windows, Linux, Mac, any operating system without any changes. So here is the conclusion. So I hope these concepts help our computers run applications smooth. So I'll brief in this conclusion with some 4 points, like user mode keeps apps safe while kernel mode controls hardware. So every mode has some benefits and these both work simultaneously with the services. And the next point is that system calls allow apps to talk to the OS. So it acts as a bridge between the OS and your system. And compilers and interpreters translate code for the execution as you require. And JVM makes Java programs run anywhere. And as I showed you in the first slide, I hope you got answer to your questions. Why your system is working without any crash? Why your system is working with security? I hope you got answers to your questions by this slideshow and thank you.